You are welcome to my YouTube channel, and if you are new to this channel, please click on the subscription button to get more videos on unlocking the secret to maths and physics. And if you are having challenges with any questions or topic on physics and maths, you can write it on the comment section so that I can be able to treat it for my next video. Thank you. Please click on that button. Welcome to today's physics class, and today we'll be talking about projectile. And what is projectile? A projectile is an object that is thrown, launched, or propelled through the air under the influence of gravity and follow a curved trajectory. Examples of projectiles are 1. A stone released from a catapult, 2. A bullet fired from a gun, and 3. An athlete doing the job. And projectile, it can be projected from the ground or top of a cliff. So let us look at projectile from the ground state. We have projectile from the ground. Let's consider this projectile using a player throwing a basketball at the net. If a player is throwing a ball with an initial velocity u at an angle theta, it will follow a curved path. And if we are to represent it on a diagram, we will have the vertical component, the horizontal component, and here is the curved path. Here's the initial velocity u. You see, here is the vertical component, and here is the horizontal component at an angle theta. And here are the key characteristics of projectile. We have the initial velocity, 1, initial velocity, which is u. We have 2 angles of projection, we have 3 acceleration due to gravity, we have 4 time of flight, we have 5 maximum height, and we have 6 the range. The flight or motion of a projectile involves 2 methods. We have vertical motion under gravity and a horizontal motion, where horizontal velocity remains constant. So let's look at the vertical motion. Under this vertical motion, we will consider 2 things. We have the time of flight and the maximum height. Let's see, time of flight and the maximum height. These are the 2 things we consider on the vertical motion. And what is time of flight? Time of flight is the time for an object that is projected from the ground state to return to the same level of projection. And when considering the time of flight, we have the time to reach the maximum height. Let's say here is the maximum height. The time to return from the maximum height to the same level of projection. So the time to reach the maximum height, let's consider it as t, and the time to return to the ground state, let's consider it as t. Since the time to reach the maximum height and to return to the same level of projection are the same, so our time of flight now be 2 times the time to reach the maximum height. So if we are to consider the time to reach the maximum height, you will resolve this initial velocity. Since we are considering the vertical component, it will now be u sine theta. So the vertical component of time of flight, u y, which is the vertical component, is equals to u sine theta. This is what we will use as our initial velocity. And we know that when an object is moving upward, it moves in opposite direction to acceleration due to gravity. So acceleration will be equals to negative gravitational force. And we know that at the maximum height, where the object will stop for a minute before returning to the ground, our final velocity is equals to 0. So v is equals to 0. If you consider this parameter using the equation of motion under gravity, we will use this equation to find the time of flight, which is v is equals to u plus at. From here now, our final velocity will be equals to 0. Our initial velocity, which is the vertical component, will now be u sine theta, where acceleration will be negative gravitational force. The final velocity is 0 equals to our initial velocity on the vertical component will now be u sine theta minus acceleration will be negative g times the time to reach the maximum height. So u sine theta is equals to g times time to reach the maximum height. If you are to make this the subject of formula, you now have t is equals to u sine theta divided by g. This is our time to reach maximum height. So for us to get our time of flight, we now have time of flight, which is the capital T, will now be 2 times the time to reach the maximum height. So our time of flight will now be 2 times u sine theta over g. This is the way of finding our time of flight. So the formula for time of flight will now be t is equals to 2u sine theta divided by g, where this is our initial velocity. This is our acceleration due to gravity. And this is our time to reach the maximum height. Let's look at the maximum height. For us to consider the maximum height, we said that the vertical component uy is equals to u sine theta. And acceleration due to gravity, since it is moving upward, is equals to negative g. If you look at this parameter, we can use the equation of motion, which is that v squared is equals to the vertical component square plus 2as. And our final velocity is equals to 0, which is 0 square, is equals to the vertical component, which is u sine theta all square, then minus, since the acceleration due to gravity is in opposite direction, will now be 2 times g, and s is our maximum height, which is equals to h. So if we are to move this to this side, we have u sine theta all square is equals to 2gh. So if we are to open this bracket, this will now be u square sine square theta is equals to 2gh. If we are to make the h, which is the maximum height, be subject to the formula, h is equals to u square sine theta square divided by 2g. This is our maximum height. This is the formula for maximum height. So we will consider the horizontal motion where range can be derived. Horizontal motion is only considered when you are finding the range of a question. So if we are to resolve this initial velocity to the horizontal, the horizontal component will be equals to u cos theta. And the acceleration due to gravity will be equals to 0 since we have a constant horizontal velocity. So acceleration will be equals to 0. From here, we can find our parameter. And we know that the time from the point of projection to the end of the projection is equals to t, which is the time of flight. So with this parameter, we can use the equation of motion s is equals to us, since we are considering the horizontal motion, t plus 1 all over 2 a t squared. I will know that the horizontal motion acceleration is equals to 0, and s will now be the range. Now have range arrow is equals to the horizontal component, which is u cos theta times the time of flight. And the time of flight, from our previous derivation, know that time of flight is equals to 2u sine theta over g. So when you put this into the equation, range will now be u cos theta times 2u sine theta all over g. So this times this now give you 2u square sine theta cos theta over g. From trigonometry, 2 sine theta cos theta is equals to sine 2 theta. So our range will now be u square sine 2 theta over g. This is our formula for range. So when resolving any question or solving any question, we consider the vertical component for time of flight and the maximum height. While resolving for range, we only consider the horizontal component. So let's solve one example on projectile from the ground state. Let's look at question 1. A projectile is fired with initial velocity of 100 meters per second at an angle of 30 degrees with the horizontal. Calculate 1. The time of flight, 2. The maximum height obtained, and 3. The range. So from here, we are given initial velocity u equals to 100 meter per second. Angle projection is equals to 30 degree, and we are asked to find time of flight. Two, which is B, we are asked the maximum height. And C, we are asked to find the range. So we know that time of flight is equals to 2u sine theta divided by g. This will now be equals to 2 times the initial velocity, which is 100, times sine 30 divided by 10. We have to take g as 10 meter per second square. So this will be 1. This divided here will now be 10. 2 times 10 will now be equals to 20 times sine 30, 0.5. So our time of flight will now be equals to 10 seconds. This is our time of flight. So let's find our maximum height. Maximum height is given as u square sine square theta divided by 2g. So our initial velocity, which is 100 square times sine 30 all square divided by 2 times 10. 100 square will now be 10 raised to the power 4 times 0.5 square divided by 20. When you press your calculator, you will have 125 meter. This is our maximum height. So to find our range, which is C, range is equals to u square sine 2 theta divided by g. Our u will now be 100 square times sine 2 times 30 divided by 10. So when you press your calculator, you will have 866 meter. This is our answer to this question. Let's consider the projectile of a body from the top of a cliff. If a ball is thrown with an initial horizontal velocity from the top of a cliff, it will follow a curved path until it hits the ground level. And if we are to represent it on a diagram, we have, say here is the height of the cliff. The ball is projected with a horizontal velocity u, which will be given to follow a curved path until it hits the ground level. And the distance from the bottom of the hill to the point where the object hits the ground is called the range. From here, the flight or motion of the projectile involves two methods. We have the vertical motion under gravity, vertical motion, under gravity. We have the horizontal constant where horizontal velocity remain constant. So let's consider the vertical motion. If we are to consider the vertical motion, we make use of the equation of motion under gravity, which are 1. V is equals to U plus AT, S is equals to UT plus 1 over 2 AT squared, and V squared is equals to U squared plus 2AS. So when considering the vertical aspect, the initial velocity of the vertical motion U is equals to 0 since it is moving from rest. The acceleration will be equals to positive g since it is moving in the direction of acceleration due to gravity. So when resolving the vertical aspect, we make use of this equation of motion where u will be equals to 0 and acceleration will be equals to g. So when considering the horizontal constant motion, we talk about range. We make use of horizontal velocity only when considering the range. If we are to consider the horizontal motion, range is equals to ut plus 1 over 2 at squared, and acceleration in the direction of the horizontal is equals to 0 since the velocity is constant. So range will be given as ut. This is what we use in calculating range. So let's consider example or solve some question related to projectile from the top of a cliff. Question 1. A ball projected horizontally from the top of a hill with a velocity of 30 meters per second. If it reaches the ground 5 seconds later, the height of the hill is dash. Let's bring out the given from the question. Here given here is the height of the hill. H, and the ball is projected horizontally with a velocity u which is equals to 30 meters per second from the top of a cliff, and it will move in a curved path until it reaches the ground level in time 5 seconds. If you look at the question, we are asked to find the maximum height or the height of the hill, and we will only consider the vertical motion. And since we are considering the vertical motion, we will not make use of this horizontal velocity because we only make use of this horizontal velocity when considering the range. That is the distance from the foot of the hill to the point of projection. So, here, when considering the vertical aspect, our initial velocity u will be equals to 0 since it is falling from rest. So g will be equals to 10 meters per second squared. With this, we can find our height. And from our equation of motion, we have v is equals to u plus at. Also have s is equals to ut plus 1 all over 2 a t square, and v square is equals to u square plus 2as. If you look at these three equations of motion, we have s, which is the height, we have u, which is the initial velocity, and we have time, which is 5 seconds, and we have acceleration, which is equals to acceleration due to gravity. From these three equations, this is the best equation we can use to find our height. So the equation will now be h is equals to ut plus 1 all over 2 gt squared. If we are to impute the value, it will now be u, which is 0, times 5 plus 1 all over 2 times 10 times 5 squared. 2 here we have 1, 2 here we have 5. So our height will now be 5 times 5 squared, which is equals to 5 times 25. Our height will now be equals to 125 meters. This is the answer to this question. Let's look at another question. Question 2. A cannonball is fired horizontally with a velocity of 50 meters per second from the top of a cliff 90 meters high. After how many seconds will it strike the plane at the foot of the cliff? At what distance from the foot of the cliff will it strike? With what velocity will it strike the ground? So let's bring out the given. Let's say here the height of the cliff, which is 90 meters, and a cannonball is fired with horizontal velocity u is equals to 50 meters per second. The ball will move in a curved path until it reaches the ground, and we are asked to find the time it reached the ground, and also we are also asked to find the range, which is the distance from the bottom of the cliff to the point of projection range, and we also asked to find the final velocity. We can only find time and the final velocity when considering the vertical motion, while the range can only be found when considering the horizontal motion. The vertical motion, when an object is falling from a top of a cliff, the initial velocity will be equals to 0 since it is falling from rest, while acceleration is equals to g, which is equals to 10 meters per second square. With this value, we can find our time. And from the three equations, we have 1, v is equals to u plus at, 2, s is equals to ut plus 1 all over 2 at squared, and the third one, v squared is equals to u squared plus 2as. If you look at these three equations of motion, we can make use of this equation 2, since we are given the height. So it will now be s, which is the height, equals to ut plus 1 all over 2 g, acceleration will now be g, t squared. And the height we are given as 90 is equals to initial velocity for the vertical aspect is equals to 0 times t plus 1 all over 2 times 10 times t squared. 2 here we have 1, 2 here we have 5. So the question now be 90 is equals to 5t squared. 5 here we have 18, 5 here we have 1. So t squared is equals to 18. Therefore, t is equals to square root of 18, which is equals to 4.24 seconds. For us to find our range, I told you earlier that we only make use of this horizontal velocity when considering the range. So, for range, rho is equals to, we use the same equation of motion to find our range, which is ut plus 1 all over 2 at squared. And for the horizontal motion, acceleration is equals to 0, since the horizontal velocity is constant. So, range is now equals to ut, which is equals to the horizontal velocity 50 times the time, which is 4.24. So our range will now be 212 meters. The final one is the final velocity. So to find our final velocity, and since we are considering the vertical aspect, we can use this to find our final velocity. So final velocity v is equals to u plus at. So our initial velocity is equals to 0 plus acceleration 10, which is equals to acceleration due to gravity, times the time 4.24. So our final velocity will now be 42.4 meters per second. These are the answers to these questions. And this will be the end of today's class. On our next video, we'll be dealing with more calculations on projectile. Please click on the subscription button to get more videos on this projectile. Thank you.